Hello and good morning everyone. I welcome you all to India's largest e-learning platform Unacademy, and I welcome you all to GATE Conqueror channel. I welcome you all to my session Antennas MCQ Series part 15. As you know, this particular series is very important here. We are trying to cover MCQs and concepts related to antennas in this particular series. Before we start, let me introduce myself. I am G Reddy, having 15 plus years of experience in teaching, guiding and mentoring GATE and ESE aspirants. I work as motivational speaker pan-India from the past 12 years, expert in field theory and communications. And this is a link where you can join us on Telegram. Once you join us on Telegram, the advantage is you get personal level support from all the faculties of the GATE Conqueror channel. Is that clear, everyone? Yes, dear. Just let me know. Is that clear? So we are into antennas MCQ series. Which is part of EMFT, and you know, on our channel we comprehensively covered the concepts of EMFT. EMFT has 5 modules. Module 1 is elements of EMF theory. Which is common for electrical and ECE. Already we have created a playlist for this on our channel with 40 videos and 50 hours of content. Module 2 is EM wave propagation. For this also we have created a playlist with 10 videos and 20 hours of content. Module 3 is transmission lines. Module 4 waveguides. Both transmission lines and waveguides will start soon, dear, but not started yet this particular modules. Module 5 optical fiber communication and antennas. Optical fiber communication I'll deal it separately. Antennas are covered in one more playlist. The series Antennas Maha Marathon series. This playlist is having 18 videos and 38 hours of content. So basically we'll try to understand how an antenna will radiate into antennas. So let us understand antenna radiation mechanism. What do you mean by radiation, dear? What do you mean by radiation? Anyone? What do you mean by radiation? So the work of antennas is to convert voltage or current waves into EM waves. It's to convert voltage or current waves into EM waves, and also to convert back EM waves into voltage and current waves. How to understand this is, for example, you are having a source, it's generating some voltage. An antenna is connected to the source. This source is giving voltage or current. This is giving voltage or current. Now this voltage or current waves, when they are given to antenna, they are converted into EM waves. What is this pattern called? This pattern is called as radiation. How it is done exactly, I explained in Antennas Mahamarathon series. I request everyone to please refer to the Antennas Mahamarathon series. Now on the other side, when these EM waves are traveling after radiation, they receive on the other side. There will be antenna and the receiver, and this EM waves are converted back to VI waves. How it converts, again I explained in Antennas Mahamarathon series. Please go through the Antennas Mahamarathon series to understand how this conversion is taking place. So this process of conversion of VI waves into EM waves is called radiation, and the conversion of EM waves into VI waves is called induction. So the two main principles that we are having is radiation and induction. Is that clear? The two main principles that we have is radiation and induction. Radiation is the process of conversion of VI waves into EM waves, and induction is the process of conversion of EM waves into VI waves. Is that clear, everyone? So for this thing to happen, we need to closely understand Maxwell equations. These Maxwell equations are derived for static fields and time varying fields. If you plot Maxwell equations for static fields, equation number 1, closed surface integral of d dot ds is equal to volume integral of rho v dv. This is the integral form. Differential form, del dot d is equal to rho v. Source, Gauss law for electrostatic fields. Second equation, closed loop integral of E dot dl is 0. Differential form, del cross E is equal to 0. Source, conservative property of electric field. These two are from electrostatics. Third equation, closed loop integral of h dot dl is equal to surface integral of j dot ds. Simplifies del cross h is equal to j. So Amperes Law. Fourth equation, closed surface integral of b dot ds is equal to 0. Del dot b is equal to 0. Source, Gauss law for magnetic fields. These both are for magnetostatics. These four equations are nothing but Maxwell equations for static fields. These four are nothing but Maxwell equations for static fields. Okay. Is that clear? How we derived it? First one, Gauss law. According to Gauss law, the amount of flux cut by any closed surface is equal to charge enclosed by the surface. Psi E is equal to charge enclosed. This is called true form of Gauss law. Gauss law in true form. With D is electric flux density given by electric flux per unit surface area, unit coulomb per meter square. If you consider small surface area ds, flux associated is d psi e. From this, d psi e is equal to d into ds. The scalar notation, vector notation, d dot ds, dot product of two vectors is a scalar quantity. From this, psi e is equal to closed surface integral of d dot ds. This is relation between electric flux and electric flux density. Similarly, when you consider charge is related to uniform distributed charge densities as line integral of rho L dl, surface integral of rho S ds, volume integral of rho V dV. Considering the general form, so general form is related to volume. Q is equal to volume integral of rho V dV, equating closed surface integral of d dot ds is equal to volume integral of rho V dV. This is called integral form of Maxwell first equation. Is called integral form of Maxwell first equation. Applying divergence on it, according to divergence theorem, closed surface integral of a dot ds is equal to volume integral of del dot a dv. Substituting volume integral of del dot d dv is equal to volume integral of rho v dv implies del dot d is equal to rho v. This is differential form or point form of Maxwell first equation. Maxwell first equation, that's the derivation for you. We will derive the next one, dear. We will derive the next one. Conservative property of electric field. We know the relation between work done, force and displacement as work done is equal to force into displacement. We also know that work done is a scalar quantity, force and displacement are vector quantity. So if you want to get a scalar, you should do dot product. Where here F is the electric force acting on a charged particle Q in the presence of electrostatic field E. Substituting total work done is Q E dot L. What does it mean is work done in moving this charge Q in the presence of electric field E by a length L is given by W. If you want to calculate a small work done, that is moving this charge Q in the presence of electric field E by small displacement dl, that is given by this. If you consider the total work done here, this is Q into integral of E dot dl defined over a path L. Now if you assume that an external agent is doing the work, what happens here? If external agent is doing the work, if an external agent will do the work, the total work done will become negative. W will become minus Q into integral of E dot dl. If you want electric potential now, electric potential is work done per unit charge dividing by Q. This is minus integral of E dot dl. Therefore, what we got here? What we got is V is equal to minus integral of E dot dl. If you want potential difference VAB, if you consider this path L to have 2 points A and B, then VAB is equal to VA minus VB, integral of minus integral of B to A E dot dl minus integral of E to A E dot dl. This means if you consider 2 points A and B, the potential difference between these 2 points VAB is equal to VA minus VB. If we extend it up to C, potential difference between these 2 points VAC is equal to VA minus VC. If we extend this up to this, potential difference between these 2 points VAD is VA minus VD. If you extend it up to this, or you close it, VA minus VA, 0. So once you close the path, the potential is becoming 0. This implies closed loop integral of E dot dl is 0. This is called integral form of Maxwell second equation. Applying Stokes theorem on this. Anyone, what is Stokes theorem, dear? Applying Stokes theorem on this, according to Stokes theorem, closed loop integral of A dot dl is equal to surface integral of del cross A dot ds. Applying Stokes theorem, is surface integral of del cross E dot ds is 0, implies del cross E is equal to 0. Curl of E is 0. E is irrotational. Rotation of E is 0. Therefore, we can say that static electric field is irrotational. This is called differential form of Maxwell second equation. Differential form of Maxwell second equation. Got it? We derived this two equations. We derived this and we have derived this equation. Next is Amperes Law. Amperes Law. According to statement of Amperes Law, circulation of H is equal to current enclosed by the loop. I enclosed is given in terms of J by J is current density, current per unit surface area, given in ampere per meter square. If you consider a small surface ds, current associated is di, J is di by ds. From this, di is jds. This is scalar notation. Vector notation, J dot ds implies I is equal to surface integral of J dot ds. This is when the current is enclosed by an open surface. I is equal to closed surface integral of J dot ds. This is when the current is enclosed by a closed surface. Substituting closed loop integral of H dot dl is equal to, now shall I take open surface or closed surface? Because on LHS you have loop. Loop can maximum enclose only open surface. Therefore, surface integral of J dot ds. This is called integral form of Maxwell third equation. Integral form of Maxwell third equation. Applying Stokes on it. If you apply Stokes theorem, according to Stokes theorem, closed loop integral of A dot dl is equal to surface integral of del cross A dot ds. Applying surface integral of del cross H dot ds is equal to surface integral of J dot ds. implies del cross H is equal to J. This is called differential form of Maxwell third equation. Differential form of Maxwell third equation. Clear? Next is last one, which is non-existence of magnetic monopole. Non-existence of magnetic monopole. A magnetic monopole does not exist. That means if you take a permanent magnet, which has north pole and south pole, if you break this magnet into two, you have subsequently formed north poles and south poles, and there is a uniform magnetic field moving from north pole to south pole. Uniform magnetic field moving from north pole to south pole. The flux psi m that is moving from north pole to south pole. Outside the magnet, magnetic flux lines move from north pole to south pole. Inside the magnet, they move from south pole to north pole, forming closed loops. So what is the net amount of flux generated here? Because this permanent magnet is generating flux psi m and it is consuming psi m, total flux generated is 0. And psi m is related to magnetic flux density B as psi m is equal to closed surface integral of B dot ds. Here this psi m is 0, implies closed surface integral of B dot ds is equal to 0. Implies this is called integral form of Maxwell fourth equation. Applying divergence on it, according to divergence theorem, closed loop integral of A dot ds is equal to closed surface integral of A dot ds is equal to volume integral of del dot A dv. Applying closed surface integral of B dot ds is volume integral of del dot B dv is 0. Implies del dot B is equal to 0. Divergence of magnetic flux density is 0, implying that B value, B is a divergence-less field or a solenoidal field. This is called differential form or point form of Maxwell fourth equation. Differential form or point form of Maxwell fourth equation. Clear? So this completes Maxwell equations for static fields. Now if you go for Maxwell equations for time varying fields, what happens in time varying fields is, first equation, closed surface integral of d dot ds is equal to volume integral of rho v dv, integral form, del dot d is equal to rho v, differential form, source, Gauss law for electrostatic fields, second, closed loop integral of E dot dl is 0, del cross E is 0, conservative property of electric field. This is for static fields. Now what change will have for time varying? This is changing now to closed loop integral of E dot dl is equal to surface integral of minus dou b by dou t dot ds. This is the change. That means what? Only static electric field is conservative but not time varying electric field. Expanding, del cross E is equal to minus dou b by dou t. This is from Faradays Law. Third equation, closed loop integral of h dot dl is equal to surface integral of j plus jd dot ds, differential form, del cross h is equal to j plus jd, where j is conduction current density given by sigma e, jd is the displacement current density given by dou d by dou t. This is from Maxwell Contribution, or also called as inconsistency of Amperes Law. Inconsistency of Amperes Law. Fourth one, closed surface integral of b dot ds is 0, implies del dot b is equal to 0, implies del dot b is equal to 0. This is from non-existence of magnetic monopole, also called as Gauss law for magnetic fields. Now if you compare static fields and time varying fields, equation 1 and equation 4 are same. Dot products are same, cross products are changing. The first change that we got is static electric field is conservative but not time varying electric field, and Ampere is only consistent for static fields. In time varying fields, the Amperes law is not consistent. We need to add some more term called displacement current density, the current that can fly in air. The current that can fly in air. Okay. So let us see how we got this. Before we do that, let me explain conservative property of charge, small property which is interlinked. Conservative property of charge. According to conservative property of charge, the rate of decrease of charge within a closed volume is equal to net outgoing current. This is minus d by dt. Q in, charge and volume, charge density are related by Q in is equal to volume integral of rho v dv is equal to I out. Now on the LHS side we have volume integral, RHS side I out. This current can be replaced in terms of current density as open surface integral of J dot ds if it is an open surface, or it can replace by closed surface integral of J dot ds if it is a closed surface. Now the question is, shall we take open surface or closed surface? Because in LHS we have volume, you should take the closed surface. Therefore this is volume integral of minus dou rho v by dou t of dv is equal to closed surface integral of J dot ds. Implies applying divergence on this RHS. This is volume integral of del dot j dv is equal to volume integral of minus dou rho v by dou t of dv. Clear? This implies del dot j is equal to minus dou rho v by dou t. It's called continuity equation. This is called continuity equation. This is from the property of conservative property of charge. So from conservative property of charge, del dot j is equal to minus dou rho v by dou t, which is a natural phenomena which is called conservative property of charge, because it states that the rate of decrease of charge within a closed volume is equal to net outgoing current, which is absolutely true. This is the main fundamental thing Maxwell has used to prove that Ampere is inconsistent. So this plays a very important role. This equation plays a very important role. Let us see one by one what is Faraday's law and what is Maxwell contribution. Faraday's law. According to Faraday's law, the induced EMF within a closed loop is equal to rate of change of flux linkage. Later on, scientists Heinrich Friedrich Emil Lenz introduced this negative sign stating that the induced EMF will always oppose the flux produced rate, where lambda is the flux linkage given by n into psi m. N is number of turns. Therefore, VEMF is equal to closed loop integral of E dot dl is equal to minus n into d psi m by dt. If we consider a straight conductor, for a straight conductor, number of turns n is equal to 1, and also we know that psi m is equal to surface integral of B dot ds. Substituting closed loop integral of E dot dl is equal to minus d by dt of surface integral of B dot ds. This implies closed loop integral of E dot dl is equal to surface integral of minus dou b by dou t dot ds. This is the integral form. Differential form, apply strokes on it. Surface integral of del cross E dot ds is equal to surface integral of minus dou b by dou t dot ds. Expanding, you get del cross E is equal to minus dou b by dou t. Very clearly, the spatial orientation of electric field depends on time varying magnetic field. The spatial orientation of electric field depends on time varying magnetic field. Clear? Last one is Maxwell contribution. Maxwell contribution. What is Maxwell contribution here? According to Amperes Law, del cross H is equal to J. What Maxwell has done is he had done divergence on both sides. Del dot del cross H is equal to del dot J. Del dot del cross H, divergence of curl of any vector 0 is equal to del dot J. Implies del dot J is equal to 0. But according to continuity equation, del dot J is minus dou rho V by dou T, which is a contradiction now. And you know this is from conservative property of charge, which is natural phenomena which cannot be wrong. That means Maxwell concluded that there is some mistake in this Amperes law, and he had coined a term called displacement current. Current which can flow in air, which later on led to EM wave propagation, which is a main source now, which is called the radiation of antenna. So antenna started to radiate EM waves. So everything is interlinked to these equations. He had introduced a term called displacement current and thereby displacement current density. Now we have done divergence on both sides. Del dot del cross H is equal to del dot J plus JD. Divergence of curl of any vector 0 is equal to del dot J plus del dot JD. Implies del dot JD is equal to minus del dot J. From continuity equation, del dot J is minus dou rho V by dou T. Minus or minus plus dou rho V by dou T. We know from Gauss law, del dot D is equal to rho V. Substituting, del dot JD is equal to dou by dou T of del dot D. Implies del dot JD is equal to del dot dou D by dou T. Implies displacement current JD is equal to dou D by dou T. From this, the final equation is del cross H is equal to J plus JD, where J is conduction current density given by sigma E and JD is displacement current density given by dou D by dou T. So from these two Maxwell equations, from Faraday's law we got del cross E is equal to minus dou B by dou T, and from Maxwell contribution we got del cross H is equal to J plus JD, or del cross H is sigma E plus dou D by dou T. Now very clearly the spatial orientation of electric field depends on time varying magnetic field. Spatial orientation of magnetic field depends on time varying electric field, which is a necessary condition for the wave to propagate. Therefore, by joining these two equations, by solving these two equations, we get Helmholtz equations. Helmholtz equations are nothing but wave equations. By solving this, we get del square E is equal to gamma square E and del square H is equal to gamma square H. These are called Helmholtz equations, where gamma is under root of j omega mu sigma minus omega square mu epsilon, which is called propagation constant given in per meter, which is alpha plus j beta. Alpha is attenuation constant, beta is phase shift constant. Is it clear? So this is the main. Now we got wave equation where the wave propagates. The basic mechanism of antenna is to radiate. The basic mechanism of the antenna is to radiate. Okay. Now if you see the mechanism of antenna, radiation mechanism of antenna, antenna will radiate when it satisfies the equation L into di by dt is equal to Q into acceleration. For an antenna to radiate, we need to have a finite length, or you need to apply time varying current. You should have finite length and you should apply time varying current, or there should be acceleration or deceleration of charges. Acceleration or deceleration of charges. For example, if you are reading a time varying current to a straight conductor, this antenna will radiate because there is a time varying current. If you are feeding this time varying current to a curved conductor, still it will radiate because there is a time varying current here. If you feed a DC supply to a straight conductor, it won't radiate. DC current means, I am applying DC current means uniform velocity of charges. No acceleration or deceleration of charges is there, and there is no time varying current. Therefore, it won't radiate. Therefore, if I apply a DC to a straight conductor, it won't radiate. If I apply a DC to a curved conductor which creates acceleration or deceleration of charges, it will radiate. This is the radiation mechanism of antenna. In further classes, we will see some more concepts related to antennas and we will solve some more MCQs. Unacademy offers two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly tests, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, you'll have all these features. Along with that, you have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study material, personalized test analysis, study booster sessions, and a customized study planner. If you go for Plus subscription or Iconic subscription, I prefer you to go for no cost EMI, where total cost will be divided by number of months without any extra charge. Moreover, you can use our team code KNR10, which gives you extra 10% off and also complete team support. That's the uniqueness of this code. If you are going for Iconic subscription, go for 1:1. It gives you 1:1 live mentoring, increasing your chance of getting a top rank. The good news for GATE and ESE aspirants is now the GATE notes for GATE and ESE are available, which are curated under the mentorship of top educators. You have materials for quick reference, accessible anywhere and anytime, and the good thing is it is available for both Plus and Iconic subscribers. So don't waste time. Try to take the subscription as soon as possible by using our team code KNR10. Congratulations to all our GATE toppers, dear. This speaks volumes about the quality of teaching that we offer at Unacademy. So we got top All India rank 1, 3 in 3 different categories, which speaks volumes about the quality. So do not waste the time, dear. Join us. Join the India's topmost faculty to crack the exam. There is a price hike from April 1st. So before the price hike, you beat the price by using our code KNR10, which gives extra 10% off and also complete team support. To get in touch with our counselor, then you have any doubts in preparation journey, subscription or latest offers, you can contact this number and get in touch with our counselor. This Unacademy Ask a Doubt feature available on app and website. You can ask unlimited number of doubts. 3 doubts at a go we can clear, and you can also you'll get the preferred solution you'll get the solution in your preferred language, and also it is very easy to ask your doubt. Just click, crop and submit. These are special class features which have interactive classes, polls for the learners, raise the hand option. You never miss a class when the notification is on, and download the lecture notes then and there. You can access anytime and anywhere. We're introducing community where we never miss any update from your favorite educator. Get session notes and practice material, and also you can share your feedback directly with Educator. This is Target GATE and ESE 2023, started March 23rd. For ECE, explained bilingual. Vision GATE and ESE 2024, started March 23rd. For ECE, explained bilingual. Target GATE and ESE 2023, started March 23rd. For electrical, explained bilingual. Vision GATE and ESE 2024 for electrical, explained bilingual. Resilience GATE 2023 for electrical, explained bilingual. Resilience GATE 2023 for ECE explained bilingual. All these courses you can join by using our team code KNR10, which not only gives you extra 10% off but also complete team support. Thank you all dear. Have a good day.